automatic wheelchair for emergency evacuation of visually challenged with auto part tracking system. The heart of the proposed model is MPU 430F5529, which is an ultra-low power consumption Texas microcontroller. It is preferred for better precision using a 12-bit ADC. The overall project has got two modules, the transmitter module and a receiver module. The transmitter module is fitted at the exit point while the four receivers are fit on the edges of the wheelchair. In case of emergency situation, the transmitter transmits and the receiver fitted on the chair receives the same. The transmitter comprises of IC 4093, which is a quad 2-input schematic trigger NAND gate provided by Texas Instruments. It is used to clean up noisy input signals by passing on a tidy sequence of zeros and ones. The next module is the receiver module. Here we are showing one of a receiver module. Actually in the model we are having 4 such modules. The receiver module has the main IC component as provided by the Texas Instrument is LM386, which is a low voltage audio amplifier. It amplifies the signal received from the transmitter before transmitting it to the associated circuitry.
The signals from the transmitter are received by the array of 4 receivers, and their sole purpose is to receive the signals from the transmitter and then amplify its power. The arrangement of the 4 receivers is in the 4 opposite mutually perpendicular directions. Our ultra low power microcontroller MSC 430F5529 utilizes this small difference in the received powers coming from all the 4 directions and then compares them and actuates the motors accordingly. The decision making is supplemented by the inputs from the 3 sensors, sensor 1, 2 and 3, which are used to avoid the obstacles in the path, and the inputs from the 3 sensors are then accordingly utilized in the decision making algorithm, which are responsible for the movement of the flowchart for our decision algorithm is as shown in the figure. The first step is comparison of the power levels. From all the 4 samples of powers, we calculate the P maximum. The P maximum calculation is used to drive and position the board in a particular direction. The motors are then actuated in the required direction, and then another decision has to be made that any obstacle is present in the path or not. When the obstacles is present, the whole procedure repeats, and when there are no obstacles in the path, the system exits.
Phase 1 of the project is the calling of wheelchair. In this phase, the wheelchair is called by the disabled person when the emergency alarm goes off. The person switches on the handheld transmitter and the wheelchair tracks its way to the person with disability. The overall system employs a complex algorithm of comparing the receiver signal levels and moving the robot in the direction as computed in the algorithm in the same manner as the board shown in this demo video. Phase 2. Evacuating the premises. In this phase, the wheelchair which has arrived to the disabled person is used to take him to the safety exit, which we consider is out of danger. The algorithm of the overall setup works in such a way that it does not only traces the transmitter and reaches to the person in need, it also avoids the obstacle lying in the path, thereby making way for the safety exit of the disabled person.
This useful technology can be used in the future, like if we want to shift the patient in the dispensaries or hospital from one ward to another ward, hence we can use this.